Alright, so we're going to find some arc length here. We got another practice problem. The function is y equals 1/5 x to the 5th plus 1 over 12 x cubed. And we're going to do that for the interval 1/2 to 1. So let's go ahead and write our formula down. That will be L equals we need bounds, don't we? L equals the integral from a to b, whatever that might be. Looks like 1/2 to 1 of the square root of 1 plus f prime of x squared, and that'll be integrated in terms of x, so dx. Alright, so we've got f of x, that's our function, so we need f prime of x. So f prime will be, first of all, let's rewrite f so it's not as hard to work with, because we've got that x in the denominator. So the f function is 1/5 x to the 5th plus 1/12 x to the negative 3. Now let's take the derivative. So derivative will be x to the 4th minus 1/4 x to the negative 4. And now we got to square that. So that's going to be a FOIL. So that's a x to the 8th minus 1/2, because when we do the outer, we'll have x to the 4th times negative 1/4 x to the negative 4. So the x to the 4 and the x to the negative 4 knock each other out. So we'll get negative 1/4 for the outer and for the inner. So two of those are going to be negative 1/2. And then the last will be plus 1/16 x to the negative 8. Okay. Oh, not good. Hold on. Okay, we went for a small adventure there, but we're back. So let's plug that into our formula. We'll have L, it's weird, isn't it? L equals from 1/2 to 1, the integration of the square root of 1 plus x to the 8th minus 1/2 plus 1/16 x to the negative 8. And that'll be dx. So let's clean that up a little bit. Integral from 1/2 to 1, square root of x to the 8th plus 1/2 plus 1/16 x to the negative 8 dx. And once again, that gives us something that we can factor, and you might not be all that familiar with it. So let's just show you what it factors into. So under the square root, this thing should factor into x to the 4th plus 1/4 x to the negative 4 times itself. So let's try and make that just a little bit neater before we continue. Try. Alright, so times itself. So if we multiply something by itself and take the square root, the duplication disappears. So we've got the integral from 1/2 to 1 of x to the 4th plus 1/4 x to the negative 4 dx. So now we're at a point where we have something we can integrate. So just reversing the power rules, everything's pretty easy here. Let's see here. This will be 1/5 x to the 5th minus 1. That goes up to negative 3. So divide by negative 3, so minus 1/12. X to the negative 3. And that'll be from 1/2 to 1. So notice the subtle differences between the original function and after we integrated. But really what we did is we took the derivative, squared it, then we added 1, that mysterious thing, and then we took the square root, which undid the squaring, and then we integrated, which undid the derivative. So it shouldn't be too much of a difference from what we started with, unless it's a different function. So as far as plugging these values in, let's clean that up just a little bit. Let's see, we're going to let x equal 1. So when I plug that in, I'll have 1/5 minus 1/12. And then we're going to subtract off, letting x equal 1/2. So that will be 1/2 to the 5th is 1/32. So let's see, that's going to be 1/160 minus 1/2, so that'll be 8. That'll be 2/3. You can put that in the calculator, I believe, but let me look at it for a second. So it'll be 1/2 on the bottom, so when I cube it, that'll be 1/8 on the bottom, but it'll flip over, so it'll be 8/12. So let's just kind of take a moment to see what the calculator thinks this should be. 1/5 minus 1/12 minus 1/160th plus 2/3, and let's see what it thinks. Ooh, what was that? It's telling me 373/480. Now I'm going to put that in. I'm going to pause it and try it again just to save you a little bit of time, but let's see. The calculator on the second try says that is correct, so we will go with it. 373/480. A little bit less than 1. Pretty short length, but we're only going from 1/2 to 1, so it has to be at least 1/2, but it doesn't have to be much more. Thank you.